Picture this nightmare scenario. Your production app is humming along perfectly, and then boom, a massive traffic spike hits and it unleashes an absolute wall of errors. Welcome to this explainer on rate limits and error handling. We're diving straight into some advanced resilience techniques from the Claude Master course.
Part 1. The 429 Retry Storm, when traffic spikes go wrong. You know that visceral pain point, right? A retry loop is aggressively hammering the API, creating a massive wall of broken responses. Your logs are just rapidly filling up with 429 errors, your users are staring at totally broken interfaces, and your system is effectively paralyzed in a doom loop of its own making.
The key stat you really need to understand here is hundreds. A single mishandled 429 response, meaning your code retries immediately without reading the retry-after header, can generate hundreds of follow-on 429s every single minute. You're literally just stacking the request queue higher and higher while absolutely zero real work gets done.
Moving on to Part 2, 3 dimensions of limits, understanding Claude's quotas. So there are 3 main dials at play here: requests per minute, input tokens per minute, and output tokens per minute. The absolutely crucial thing to remember is that the API enforces all 3 of these dimensions simultaneously. That means your app can hit any one of them independently, which triggers a block even if your other 2 dials are totally fine. But how do those dials actually reset? Well, they rely on a token bucket algorithm. Think of it as a continuous drip refill of capacity rather than a step reset clock that magically clears your slate right at the top of each minute. Because that capacity trickles back in constantly, spreading your requests out evenly is always a vastly better strategy than just bursting everything at the start of a window.
Part 3. Backoff, jitter, and tenacity. The silver bullet.
To actually build this out, we're going to look at one prime example. Using the tenacity library, there are 3 logical steps that work together here. First up, is retryable ensures we intercept transient errors, things like 429, 500, and 529. Second, wait exponential applies an increasing delay, so it starts at 4 seconds and ceilings out at a maximum of 60. And finally, wait random adds up to 2 seconds of random delay.
Now that final piece, jitter, that is the absolute key ingredient. If you have, say, 10 worker threads hitting a limit simultaneously, adding jitter means each thread is going to sleep for slightly different durations. This completely prevents a synchronized retry spike where they all wake up at the exact same millisecond and just knock the whole system down all over again.
You also really need to identify exactly what kind of wall you just hit. A 429 error means you exceeded your quota. A 529 error, on the other hand, means Anthropic's infrastructure is temporarily overloaded. Both of these situations require that backoff strategy we just built, but keep in mind, only the 429 actually counts against your own organizational usage tracking.
Okay, let's rapid fire through a few advanced use cases. If your app literally can't tolerate any retry delay, you'll want to use proactive client-side throttling. If you're dealing with bulk offline work, use the Message Batches API. It avoids synchronous 429s entirely, plus it's 50% cheaper. For streaming, you absolutely must wrap the entire iteration in a try-except block, because those errors can definitely strike midstream. And finally, for agent loops, always inspect the stop reason to catch pause turns.
Which brings us to Part 4, key takeaways for production, your resilience checklist. Synthesizing all these concepts together is what creates a truly robust, self-healing system. So, here are the major takeaways. First, remember that limits hit RPM, ITPM, and OTPM all at once. Second, always read the retry-after header. Third, add jitter so your workers never retry in lockstep. Fourth, wrap those streaming responses end-to-end. And lastly, just treat 529s as Anthropic is busy.
So, I want to leave you with a question. Is your application prepared to gracefully handle a sudden 10x traffic spike without falling over? Really take a hard look at your current error handling setup and ask yourself if it would actually survive the storm.
If you're ready to bulletproof your systems, you can find full-worked code examples and the most common pitfalls to avoid by reading the complete chapter over at cloudmaster.net. Thanks so much for joining this explainer. Stay resilient out there, and I'll catch you in the next one.